Okay, we're problem number 13 now. So it's 14x squared plus 13x plus 3. Okay, if I were looking at the problem, the first thing I do is saying, I wonder if I can do it. And there's all kinds of tricks for it. But I'm just thinking that, maybe I can do it. So what do you put down? I'd probably put down a 3 and a 1, right? Now the 14 is more challenging for me. It could be 1 and 14, or it could be 2 and 7. Oh, there's no guarantee it's going to work, by the way. If they're not, you know, rational numbers, this is not going to work out. But I'm looking at this thing, and I'm kind of curious about what might do this for me. And I'm kind of looking at it, and I'm going to say the 2 and the 7 looks much more reasonable to me than the 1 and 14, because I can't see the 1 and 14 giving me that 13 in the middle, by the way. But I do see that, the 2 and the 7 might do it. I'll put this over here. When I say might do it, I'm not guaranteeing anything. I'm just guaranteeing that trying is something you want to definitely look at. So I'm looking at this over here. And by the way, notice everything's a positive, so I'm going to say plus plus. Now, do I get 14x squared? I do. In trial and error, this always works, by the way. Do I get 3 in the end? I do. Do I get the middle, though? That's my big concern, by the way. Well, I see 7x and 6x, and 7 and 6 is 13. This worked like a charm. It's just the correct answer over here. Okay, very little work, all right? Now, someone says, if you didn't get in the first try, what would you do a second try? There's not many tries, by the way. If I were to use the AC method, though, and again, there's nothing wrong with this. A lot of students will do that. Write down the A, that's 14. Write down the C, that's going to be, I'm sorry, I should write the B down first. Write down the B, that's 13. And write down the C, which can be 3. A times C is going to be, well, that's 30 and 12, 42. I need to find two numbers that multiply together to give me 42, and the same two numbers, when added together, would give me the B, which is 13. All right? Now, kind of looking at it, let's take a look at that. And again, it really goes back to, you still have to figure this out. You're still thinking of numbers, and you're seeing the 42, and I'm going to say 7 and 6. And why is that? 7 times 6 is 42, and 7 plus 6 is what we want, which I didn't mean to put the plus sign there. That's a little overkill, isn't it? All right? So 7 and 6. All right? So what do? And I'm just going to write down one way now. It's 14x squared. Now, whether I put 7 first or 6 first doesn't matter. I'm going to put 7x, and then I'm going to put 6x. I want to point out this has got to be equal to the original polynomial. And what's going to be 14x squared plus 13x plus 3. All right, what do you get over there? Well, by grouping, I get a 7x. That would give me 2x plus 1. On the last group, I get 3 comes out, and that's 2x plus 1. What do you get over here? Common factor between the two terms is 2x plus 1 now, and then 7x plus 3. Are we getting the same answer? Of course we're getting the same answer. Order of the factors doesn't matter, by the way. Now, again, if you went back to the other method, the method that they're promoting here, which, I'm going to say it's new to me. I've never seen it before, and that doesn't mean it's a bad method. And a good method is what allows you to factor the problem, by the way. Now, what do they do over here? They rewrite the problem, and they do x squared. It's not an equivalent problem, by the way. It's related, plus 13x. And what they do is 14 times 3. Well, 14 times 3 is going to be 30 and 12, 42. Kind of like the AC method, right? So what do you have here? X. I'm looking at this over here. X. I'm going to say, looking at it, 6 times 7 plus plus. All right, that's factorization. What they do is that the coefficient now 14, throw it in there. And again, if this is working for you, that's fine. You can start crossing this stuff out, though, because it's not really equal to that. What they do now, divide by, or I should say reduce it So this would be divided by 7. And what is it going to be divided by? It looks like 2. And what do you get over there? Let's write that down. That's going to be 2x plus 1. And that would be 7x plus 3. What do you get over here? 2x plus 1. And then 7x plus 3. I would check it. And what do you get over there? 14x squared. The reason for checking it, there's so many steps over here that I'm kind of, wondering, I get lost in the steps, and did I do everything I needed to do? Well, what do you get here? 6x. And then I get a 7x. And then you get 3. And does it give me back what I expected? It does. I get the 14x. I get the 3. And if you took those two terms, you get 13x. So this works out fine. The question again is, are we getting the same thing? Of course we're getting the same thing. 2x plus 1 times 7x plus 3. All right, so let me just review what I would have done. I would have just done trial and error. Now, does trial and error always work? No. But I'll be honest with you, you see a variety of different methods, and I'll be honest with you, sometimes I do go to the AC rule because I'm more and more familiar with the AC rule. And I just don't really go to that my first stop, by the way. But I like to do trial and error. So you might say, no, I like to do AC method. You might say, I like to do what black pen, red pen is doing. By the way, black pen, red pen's name, I believe, is Stephen Chow. And, he's a talented YouTube entertainer when it comes to, doing math problems. And I would recommend maybe looking at him do how he does the problem. How quickly he does it, maybe how if he takes a different route than I take. The bottom line, the more you see, the better it is for you, by the way. And it's something, also the more you read, the better it is for you. Thank you.